Okay, going over homework help here, or homework questions from chapter 5, and we're looking at problem 31. So I'm going to read through it. While I'm reading through it, I'm going to make some notes. So this is what I talked to a couple people as I was coming around, that like, even if you're unsure how to do a problem, I got to see something on your paper. So one thing that you could do, strategy you should always do is, as you're reading a word problem like this, take some notes about the important information, and at least get that down on paper. So 31 is talking about Marvin and Leela. I'm going to just abbreviate M and L. They're on bumper cars. They're at opposite ends of a 100-meter track heading towards each other. So here's my 100 meters. One of them's going this way. One of them's going this way. Opposite ends. It doesn't say who's on the left and who's on the right. I'm going to say Marvin's on the left and Leela's on the right. Marvin's moving at a rate of 5.5 meters per second, and Leela's going 3.2 meters per second. So maybe I got to put this on my picture, 5.5 and 3.2. How long does it take for them to collide? Okay, so we're looking for some time. Okay, so at least get something down on paper. It's already set. Just set it on my desk over here if you would. All right, so what are we going to do here? I think this looks like something from Algebra 1. You guys remember the tricycle races last year in Algebra 1? That would be for those of you who are sophomores. You guys remember the tricycle races? No, the big race? Come on, it was the coolest one. There was a clown. They went backwards. Yeah. So this reminds me of this. Was in chapter 2 of Algebra 1, and it was all about linear equations. So I think this is prime for a linear equation, y equals mx plus b. That's how I'm going to tackle this. So for each of these people, I need to know a starting value and a change, and the change is just going to be the speed that they're going. All right, this is what's changing their position, is the fact that they're moving at these speeds. So that would be my change, and then the starting value for each of them is going to be like my y-intercept when I write the equation. So they didn't tell me who was where, but I'm going to say that Marvin's here at 0 and that Leela's over here at 100. So Marvin's starting at 0, Mervin, that is, and Leela's starting at 100. And I need to make one change to Leela's speed. What do I need to change about Leela's speed? Marvin's going to the right, so Marvin's getting closer and closer to 100, but Leela's getting closer and closer to 0. What do I need to do with this speed here? What do you think? Let's make it negative, right? Because she's moving, her distance from the start, if we want to think of the left-hand side as a start, her distance is decreasing, right? She's getting closer and closer to 0, so her change should be negative. Agreed? So then we can write a couple equations. Mervin would be y equals 5.5x plus 0, and Leela would be y equals negative 3.2x plus 100. So we got a couple equations, and then we just need to use our algebra skills to solve these. So we're just getting into this in Algebra 1 right now. Systems of equations. Last year, you learned a method called equal values. When you had y equals for both equations, you can just take the two equations and set them equal to one another. So 5.5x, I'm going to leave the plus 0 off, equals negative 3.2x plus 100. And now I have an equation that I can solve for x, which would be my time. Okay, so I'm going to leave the algebra piece, the last few steps of solving that equation to you guys, but that would be the setup. Any questions about that one? It's been a while since we've done this. You're going to be doing it a whole bunch in Algebra 2 next year. You will see more and more of these types of problems throughout chapters 5 and 6, just to kind of jog your memory on those Algebra 1 skills. All right, so there's 31. 33 was by far the most requested one. So let me draw my picture here. So it's an interesting looking shape. So it's kind of like a rectangle with a little triangular bit sticking off of it. And they told us that this is 20 degrees, which is strange. We got 24 meters here. We got 18 meters here. We got 16 meters down here. And we're finding area and perimeter, correct? So what do I know? If I chop this off right here, this would be 18. How much would this side be here? That would be 6, right? You see where I'm getting that from? Is that helpful to me? I guess it's going to be helpful for finding the area of this triangle. That'll end up being the height of the triangle, right? But I still need to know what the base of this triangle is, and I need to know what its hypotenuse is too, because we need the hypotenuse for the perimeter, we need the base for the area. And actually, I think we need this base also to figure out how long this piece is. So really, this triangle is kind of the big question. If I could figure out these two sides, I think I'd have all the information I need. So let me sketch it off to the side here, see what we can do with this. We do know that it has a side of 6 and it has an angle of 20, not 0. So I need my other two sides. Let's do this one first. What do you want to call it? X, Y, R, Y, Q. Heard Y first, we'll go with Y. Do you think you'd be able to set up a trig equation to solve that? Why don't we all do that right now, unless you've already done this one? Did you already set up a trig equation when you did it in your homework? Okay, I want you to do it right now then. Let's practice. Everybody, pick up your pencils. Write me a trig, draw this triangle, write me a trig equation. Unless you completed the problem. Unless you've already completed the problem, I want to see you writing down right now. Let's see what we got here. Six and the Y. That would be adjacent. Looks like a tangent equation. You got it? Did you solve it already? How many decimal places are we rounding to here? Doesn't say. We'll just go one decimal place, I guess. All right, are we there? Did you come up with 2.2? About? All right. Cool. So we've got that. If that's 2.2, then I now know how big this piece is, right? 16 minus 2.2, right? We're just taking that away from 16. So 16 minus 2.2 is 13.8. And that's good because we'll need that for our perimeter. So now all I need is this. I've got enough information to find the area of this triangle now. I got a base and a height. I'm just missing the hypotenuse. So I can go back to this triangle. Let me draw another copy down here, just to kind of make this clear. Again, we got 6, we got 20, and I'm going to solve for this side now. We'll call this, well, why don't we just call it H because it is the hypotenuse, right? Let's solve for H. So we've got our opposite side and our adjacent. So this time we're going to be using which trig function? Adjacent and hypotenuse would be, that's cosine, right? Adjacent and hypotenuse. So we'll do a cosine equation for this one. Angle still 20, adjacent over hypotenuse. So 6 over, I don't know what H is, so I'm just using H as a variable. Do y'all remember how to solve an equation like this? Are we going to do that inverse thing for this or no? Not for this one. When your variable is in your fraction, you're going to cross multiply. The only time we do an inverse is when your variable ends up inside the parentheses. So that thing that we learned on Monday, we got to be careful that we're not overusing it. The only time we do an inverse is when we have a variable inside the parentheses. In this case, we're just going to cross multiply. So I'd do H times cosine 20 equals 1 times 6 is 6. And then we do one final step to get H by itself. We divide by cosine 20 on both sides. That's going to cancel. And then we just need to divide 6 divided by cosine 20. Coming out to about 6.4. So now we've got all the information we need. I'm going to leave the area and perimeter portion to you. Make sure you know how to do that. We had to do a little bit of trig to get there. Question. Oops. Oh, because that would have been smart. What a great suggestion. Hang on, let me go back down here. Suggestion was, why didn't we just use Pythagorean theorem? Once we knew this was 2.2, we already had two sides, right? Now, did you get something around 6.4? Okay, that's good. So we did it 2 different ways, got the same answer. Thank you for sharing that. I didn't think about that. Yeah, we've got Pythagorean theorem, and then the other rule that we have for triangles, if we were looking for this angle right here, we wouldn't need trig for that. We could just use the fact that the angles all add up to 180. Awesome, great suggestion, thank you. Okay, that gave us an opportunity to review trig stuff. I need a hand really quick. Can somebody pass out some papers for me? Oh, you're awesome. Anybody else want to help? Thank you. You guys want to split them and do half the room each? Does anybody else have any burning questions from the homework? We do one more while we're passing out papers. I know some people mentioned some others, but I can't remember what they are at this point. Other questions from homework? All right, we'll call that good.